Alright, hey guys, here is the key for section 12 review. So I was having some issues and I'd already started with my camera and the focus, so here we go. Jose has a circular rug on his bedroom, so pretend I just drew the circle. The area of the rug is 36 pi. So they asked what's the diameter of the rug. You know the area formula of a circle is pi times radius squared. So all I did was replace the a with 36 pi, have it equal to the formula pi r squared, cross off the pi's. 36 is equal to r squared, take the square root of both sides, and the radius would be 6, which is great, except they asked the diameter. So radius is from the center out towards the edge, that's radius, so diameter is just double that, which makes it 12. Alright, moving on. So Sergio works at his father's electronics shop after school. He needs to drill a hole at each of the points A, B, C, D, and E on circle P, which is right down here. Sorry about that. Okay. If Sergio drills the hole so that this should have been angle APE, so this angle right here, this is 120 degrees, and the other four central angles are congruent to each other. Okay, so all these guys are all congruent. Cool. What will the measure of angle CPD be? Alright, so CPD, they want to know what's this one, right? Right in there. What is that one? CPD. Okay, so easy, right? Around a point, there's a 360 degrees. So all we got to do is this. Take 360, subtract the 120 that we see there. We're left with 240 degrees from here to here. And we know all these little sections here are congruent, so let's just take 240 and divide it by 4. Okay, 240 divided by 4, and that is 60 degrees. Okay, so that means each one of these is 60 degrees in here. Great, and it was so nice that we just want CPD, so we just want one of those 60s right there. Boom. Awesome. Oh, and they labeled degrees. Great. 3. Ashley maintains a circular flower garden that has a radius of 40 feet. Okay, so I know it looks bad, but right there, that's 40 feet. Okay, she would like to construct a fence around most of the garden, as indicated by the solid black line in the diagram. She wants to keep an opening to the garden that makes a central angle of 35 degrees. So right here's 35 degrees. How long to the nearest foot does the fence need to be? Okay, so we need to figure out what the fencing needs to look like from here all the way to here. Okay. Okay, so we know this is basically the circumference, and you know circumference is pi times d. In my class, we call it cherry pie is delicious. That's the circumference formula. So I'm going to go and figure out what the circumference of this guy is, which would be pi times diameter. Well, so the radius is 4, so if we double that, that gets us 80. This is the full circumference all the way around, but I only want from here to here, so I don't want a full 360 degrees around this circle. I actually want what's 360 minus 35. Well, let's see, that's 325 degrees, so that means from here to here it's 325 degrees. I only want 325 degrees of the circumference, so I multiply that times the part divided by the whole, right? 325 degrees over 360. And then we're going to see what we get. That's going to be the part of the circumference we want. So if I have my calculator here, I'm just going to do everything without the pi here. I got 80 times 325, and then I'm going to divide by 360. Okay, so I get a crazy little decimal. And now I'll go ahead and multiply that times pi. And we get this, which is cool. It's all good. 226.8928, yada, 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 yada. Okay. Alright, so as far as what do I want, they said how long the nearest foot does the fence need to be to the nearest foot. Alright, that's the nearest whole number. So I use this to round me up. We're at 227 feet. 227 feet, yeah. Good. Good. Rolling. Alright, match the angle with the correct radian measure. Okay, so we talked about how to go from degrees to radians and back and forth. Alright, it's everything to do with 180. So if I want to go from degrees to radians, I take the degree and I multiply it by pi time over 180. Alright, it's kind of like your special little formula. So if I do 60 degrees, alright, so I have 60 degrees, I'm going to multiply it by pi over 180 degrees, and then I just simplify. So, I mean, if I go across here, you have 60 pi over 180, and we simplify, like cross off your zeros, right, simplify, what number goes into 6 and 18? It's 6 divided top and bottom by 6.
Tom Wallback, please dial 1013, Tom Wallback.
And pi over 3 is my answer. Okay, so I look up here, where's pi over 3? Here it is, put a little x there, boom shakalaka. Alright, so same thing with 90. Okay, I do the exact same thing with 90. 90 degrees times pi over 180. I get 90 pi over 180. If I simplify that, okay, 9 over 18 divide top and bottom by 9. And that would be 1/2 pi, or just pi over 2. Pi over 2. Okay, and then you got 270. You run out of room, so I'll do it up here. Right, so again, I take my degrees, 270 degrees. Multiply it times pi over 180. I got 270 pi over 180. And then I simplify. So zeros cancel out. What number goes into 2718 is 9. Divide by top and bottom by 9. And that would be 3 pi over 2. Alright, so if I look down here. Oh, that's never good. So the answer is not there. Let's just pretend that this was incorrect. It should be 3 pi over 2, and then we'll say it's right there. Okay. Alright. Number 5. Roderick works for JB Spas. He's installing a circular spa. Ooh, yeah, let's do a picture. Alright, that will be enclosed by a square deck. Alright, so now I got a square deck that encloses the spa. Love pictures. The radius of the spa is 4.7 feet. So the radius, so from here to here is 4.7 feet. What's the perimeter of the deck in feet? What's the perimeter? Okay, so the deck, again, going back, the deck is this square thing, right? If the radius of the circle is 4.7, means the diameter would be double that, right? So if I double, oops, sorry, 4.7 doubled, what is that? I don't know. My brain's not working. I don't know. It's 9.4. Okay, so that means this whole distance right here is 9.4. Well, it's a square, right? So over here is 9.4 as well. Cool. Now they wanted the perimeter. Okay, perimeter is
please dial 1013, Miss Singleton.
Distance all the way around. So this is 9.4. This is 9.4. All right, so we add all those up together, or multiply 9.4 times 4, and we get 37.6. What do we got? Feet. Boom. Shakalaka. All done. What is the equation of a circle with center 2, 4 that passes through the point negative 6, 12? Okay, so in order to write the equation, I mean, you guys can start this off. We know the center, you know, the circle goes x, we do opposite, minus 2 quantity squared plus y, minus 4 quantity squared plus equals to the radius squared. Well, how do I know the radius? Well, you got to figure the distance from the center to another point. Oh, you got to figure the distance. Whew. All right, pause. And we're back. Okay, so we have always talked about finding distance with the Pythagorean theorem. I'm totally doing that. It's totally going down. Hopefully I did enough there. Okay, so I'm going to plot 2, 4. 2, 4 is my center. My other point is at negative 6, 12. So 3, negative 6 here, 12. Okay, so 3, 6, 9, 12. Where do those meet? Right there. So my circle is really big, right? So this would be the radius, and I draw it like right here if I wanted to, because this is, again, this is the center. But in order to come up with my equation, you need the radius squared. That's what goes there. So if I want to figure out the distance, we can just use Pythagorean theorem. Here's your right triangle. So this goes up 1, 2, 3, 4, 5, 6, 7, 8. This goes over 1, 2, 3, 4, 5, 6, 7, 8. So if I do a Pythagorean theorem, I go 8 squared plus 8 squared equals c squared, and here's your c. Alright, 64 plus 64, and that's 128. Take the square root of both sides. Oh, well, okay, so this distance would be the square root of 128. Let's not do decimals for a second, right? So this is the square root of 128. Alright, so if I looked at this, it's the radius squared is the formula. So this is my radius, and I had to square it for the formula. These cancel. I'm just left with 128. Amanda is designing a logo for her new jewelry company. The logo is a regular hexagon inscribed in a circle. The space between the hexagon and the circle will be plated in gold. So we're going to do some gold plating right here, like all the way around. Cool. If the diameter of the circle is 20 centimeters, so that means from one point to the other is 20 centimeters, what is the area of the space that would be filled with gold? Round to the nearest digit. Okay, and this is all gold. Okay. Yeah, this is a fun one. Total fun one. Okay, so this is what I'm going to do. I am going to only focus on one section. So I'm going to figure out this. I'm going to figure out the area of this whole section. Then what I'm going to do is I'm going to figure out the area of just the triangle. When I have the green, I'm going to subtract my triangle, my purple. What I'll be left with is the gold plate for just this little cute region here, and then I'll multiply it times 6. That's my game plan. Okay, so let's talk about area of this whole section right here. That's the area of the sector. Okay, so we know it's the area of part of a circle. Well, we know the formula for a circle is A is equal to pi times r squared. Well, my radius in this case would be 10, and it's half of 20, which is 100 pi. So the area of this whole circle is 100 pi, but I only want one section for right now, right? So I'm going to take that, and then I'm going to divide it by how many sections would there be? Well, that's 1, 2, 3, 4, 5, 6. 6 sections. So let's divide this by 6. All right, and let's see if I did that. Well, I mean, you could get a decimal. Let's actually, I'm just going to simplify the fraction. I mean, it's 50 pi over 3. It's the same thing. So the area of this whole thing, right? The area of the sector is 50 pi over 3. So I'm just going to do a little picture. It's like an ice cream cone. Yum. Alright, now, I want to find the area of just a triangle. Well, what I know about the triangle is this. Okay, so I'm going to draw a triangle. The triangle, I know this distance right here is just the distance of the radius, which would be 10. Okay, and then I have to think about, well, what's the area of a triangle? The area of a triangle is the base times the height divided by 2. Okay, well, the base of a triangle, in this case, would be like right here. This is the base. The height would be straight to the tip top, base times height. So I have to figure out these distances knowing that this side is 10. I mean, this would be a right triangle, so that might help me at some point. Okay, so what can I do from here? Well, it would be helpful to know how many degrees this little guy is right here. Alright, that is right here. Well, around this point, there's how many degrees? 360. So 360 divided by 6 is what? Okay, so 360 divided by 6 is 60 degrees. So I know that this little guy right here, this whole thing is 60 degrees. Okay, if that whole thing is 60 degrees, I mean, that would mean if I split this in half, this is 30 and this is 30. Okay, well, you have something to work with here because you have, I mean, you have a right triangle right here. I should have drawn this bigger. Matter of fact, I think I will. Sorry, guys. It's just, alright, so I'm going to make it a little bit bigger so we can see what's going on. Right, so we split this in half. So this was 60. That means this is 30 and this is 30. You have 90-degree angle. This was the original radius. Okay, so I have to figure out the distance here and here. Well, you have a right triangle, kids. You got to angle a side. You got to figure out the other side. Use trigonometry. That's SOHCAHTOA. So, like, let's just say I want to find this side first. From this angle, forget about this part of the triangle. Alright, this is your adjacent side. Cross triangle, this is a hypotenuse. A and H, that means use cosine. That's the ka. So cosine of 30 degrees is equal to the adjacent of the hypotenuse. I don't know the adjacent. I need to figure that out. I'll use A over my hypotenuse, which is 10. Okay, so I want to solve this for A. We multiply both sides times 10. Okay, so A would be, let's look. 10 cosine 30. Alright, that's a weird looking answer there. So in my calculators, I'll make it a decimal. Okay, so it's 8.66, yada, yada, yada. Okay, so 8.66, we'll call it good right there. Okay, so I know that the height of this triangle is 8.66. There's your height. Again, remember we're trying to find the area of this triangle, so we have the height. Now I need to find the base. Well, we're only going to find half of it, and then we'll dub it to actually get the base. Okay, so again, you have to do a little bit of trig work here. So if I do the exact same idea again, but now I got to find this guy over here. I need to find this side. So from your angle 30 degrees, alright, you've got an opposite, and you still know the hypotenuse, O and H. And so I'm going to put a B here just so we can understand we're trying to find this guy. Alright, so I want to find this side, O and H, that's sine. So sine of 30 is equal to my opposite, which is B, over my hypotenuse, which is 10. Let's solve. Times 10 times 10. Plug in my calculator. 10 sine 30 equals, oh, that's a pretty number. Thank you, Jesus. Awesome. 5. Okay, so coming back up here, alright, so B, just cross out, it's 5. Now remember, I wanted the whole base, right? So this would also be 5, which makes this whole side 10. Whole side's 10. Okay, so I come back to what I have here. I have a base of 10. I've got a height of 8.66. I want the area of this triangle. I'll take the base times the height. Okay, so the area is base, which was 10, times height, 8.66. Divide by 2. Well, let's see what that equals. 10 times 8.66 equals, divide by 2, 43.3. So the area of this triangle is 43.3. Okay, so where do I go from here? So going back to this problem, we knew the area, and I didn't make it a decimal, but the area of this sector was 50 pi over 3, and the area of the triangle is 43.3. So I said if we subtract these two, we will be left with what's in gold, which is just this one little section right here. Okay, so let's do this in my calculator. I'm going to take 50 pi divided by 3, which is this. I'm going to subtract 43.3. I'm going to get this. Okay, so the area of this one little piece right up here is 9.059, yada, yada, yada. Then I'm going to multiply times how many I have. 1, 2, 3, 4, 5, 6. Times 6. Okay, so they said round to the nearest digit, which is tricky. Nearest digit I'm going to go with is just the nearest whole number. We're going to go with 54. Ooh, that was rough. Okay, moving on. Number 8, the equation is given, describes the circle, complete the square to find the center of the circle. Okay. Alright. Okay, so completing the square. So we talked about when we do this in class, you've got to put all your x's next to each other. So let's go x squared, minus 4x. Skip a space. Then you've got plus y squared plus 2y. Skip a space is equal to your b over on the other side. Okay. Okay, so we'll complete the square. We take half of this number and square it, which is negative 2. Squared is positive 4. If I add it to that side, I got to add it on the other side of the equal sign. Same thing here. Half of 2 is 1. Squared it is 1. Add that to this side as well. And then we can factor each of these. So the trick was, I mean, essentially what two numbers multiply get you 4, add to get you negative 4, it's negative 2, negative 2. So it'd be x minus 2 quantity squared. Really the trick is just this, take half of this number, whatever that is, it goes right there. Cool. Drive down your plus sign, same idea. So with the trick, it's just half of 2 is 1. Equal to over here, so it looks like you have b plus 5. Complete the square to find the center of the circle. The center of the circle is, so remember, this is the equation. The center is actually opposite of those numbers. So it'd be positive 2, negative 1. Now, the radius of the circle, okay, now they're telling you the radius of the circle is 7 units. What is the value of b in the equation? So going back here, well, if your radius was 7, think about what would it have to be on this side of the equal sign. Well, if it was 7, it would be 7 squared, which is 49. Well, you already have a 5 here, so what would b have to be in order for b plus 5 to be 49? It had to be 44. Right? Because 44 plus 5 is 49. Done.
I don't take this the wrong way, but I hope I don't.
Alright. Rolling on, number 9. What the equation of a circle is this? Which diagram below shows the graph of the circle? So we know our center would be at negative 2, positive 4. The radius would be 4. So let's see, negative, that's 2, negative 4, no. This is at negative 2, positive, that's good. Is my radius 4? 1, 2, 3, 4, sure, it's B. Right, just to make sure, okay, this is at positive 2, negative 4, no, not the center. This is at negative 2, positive 4, however my radius is 2. Wrong one. Okay, so B was correct. What are the answers closest to the area of the shaded segment? Okay, so this is similar to kind of what we just did with that crazy gold problem. You know, I mean, this is, so you got 90 degrees here. So what we're going to do is this. We're going to find the area of the entire sector, right? So if I'm finding the area of this whole thing, we're going to use the area formula of a circle, pi times radius squared, which is pi times 11 squared. That gets me pi times 121. That's the full area of the whole circle. If I only want this part, we're going to multiply it times the part divided by the whole, which is 90 degrees over 360. Okay, let's see what that is. 121 times 90 divided by 360 is 30.25 pi. I left pi off just to keep my answer as exact as possible. And then what we need to do is we need to subtract. We need to subtract the area of the triangle there again, because they actually only want. Oops, they want that shaded region here, right? So we need to subtract the area of the triangle from this sector. Okay, so again, the area formula of a triangle is base times height divided by 2. Okay, so my base would actually be 11, and just fancy that, my height would also be 11 because it's another radius. So we've got 11 times 11 divided by 2. Okay, that's 121 divided by 2. So this is the area of the triangle. So what I'm going to do is I'm going to take the area of the sector, which is this guy, the ice cream cone, and we're going to subtract the area of the triangle. So we're doing 30.25 pi minus area of the triangle, 121 pi, or sorry, 121 over 2. And what is that equal to? Let's look. So 30.25 pi minus 121 divided by 2 is equal to 34.53. And what answer is closest? So this will be a multiple choice question. You're just going to go with which one's closest. So if I would have said your answer choices were 30, 34, or 35, this is closest to 35. We'll go with that. Oh, and that would be centimeters squared, sorry. Okay, 11. The area of the sector is 24 pi. Find the measure of angle FAN. So actually they want you to find this angle. Okay. So again, we know that the area of the whole circle, like this, area of this whole circle would have been pi times radius squared. If I want the sector, you do it times the part degree over the whole degree, which is 360. Okay. So the area is 24 pi, goes over here. It's equal to pi times your radius squared, which is 12 squared, times, we don't know how many degrees the part is, but we know that there's 360 degrees in the full circle. So at this point, we're just solving for x, right? These pi's can cancel. That's easy. Let's go ahead and do, let's just do some backwards math, right? This is divided by 360. I'm going to multiply both sides times 360. And so I'm left with 12 squared, which is 144. X, and over here, that's a big number, 360 times 24. All right, divide by 144 then. And that's 60. So x is equal to 60 degrees. Awesome. And 12, calculate the area of the shaded region. Leave your answer in terms of pi. Oh, easy. You're going to take your large circle, that area, and subtract the small circle area. All right, and area is equal to pi times radius squared. So the large circle is pi times your radius, which would be 5 plus 3, which is 8 squared. So that's, I'm just going to rewrite the 64 pi. All right, and then I'm going to find the area of the small circle, which is pi times radius of 5 squared, equal to, all right, so I'm going to write that 25 pi. All right, and so we're going to take the large one, subtract the small one. 64 pi minus 25 pi is what? 39 pi. And they say to leave your answer in terms of pi, which is great. So your answer is 39 pi centimeters squared. A dinner plate fits snugly in a square box with a perimeter of 24 inches. What's the circumference of the plate? No big deal. Got a square box. You got a plate that fits snugly in there. Perimeter is 24. If it's a square, we're going to take 24 divided by 4, which is 6. So each of these sides is 6. What's the circumference of the plate? Well, the circumference is pi times diameter. Oh, that's easy, right? Diameter is 6. So all I got to do is take pi times 6, and that's my circumference. They sure didn't tell you how to round that. So 6 pi would be the exact answer. If you wanted something more like decimal-like, we're going 6 times pi. And that would be 18.85. I don't know if we go to hundreds. All right, so either of those answers would be good. I'm guessing they're going to go something like that. So 18.85, we'll go with that. 14, there are 4 saucers, each with a circumference of 24.3 inches. Will the saucers fit side by side in a square box with perimeter of 80 inches? Goodness. Okay, so you've got a square box. Perimeter is 80 inches. We know on a square all sides are congruent. So if I take 80 and divide by 4, that's 20. And so there are 4 saucers, each with a circumference of 24.3. Okay, so the question is, can they fit in this square box? This is poorly worded. It could have been diagonal. I'm just guessing they're supposed to fit this way. All right, so the question, you basically need to figure out what the diameter is of all these saucers and see if they fit in a distance of 20. Well, circumference is equal to pi times diameter. They give you the circumference of one is 24.3 for 1. So if I want to figure out the diameter, I divide by pi both sides. And diameter would be what? Who knows? I don't know. 7.73, yada, 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 yada. Okay, so this is 1 diameter. You've got how many plates there? Well, there's 4, so I'm going to multiply that times 4. And I'm going to get a distance. So from here all the way to here is actually 30.9. Right, in the square box, one side was 20, so is it going to fit? The answer is no. Not fitting here. If I want to know how much over did we go, I mean, you could subtract 30.9, subtract 20. I mean, we're over by 10.9 inches. We're over by 10.9 inches. Rough life. Last one. Find the coordinates of C and the radius of circle A. Oh, that's not bad, y'all. Easy peasy. Lemon squeezy. So C is right here. Right? The X coordinate would be the same as above B, which is 11. The Y coordinate would be the same as A, which is -1. Only answer choice you got there is D. I mean, then you want to double check your radius. You just got to do Pythagorean theorem. Right? So from 7 to 11, that's 4. If I go from -1 to -4, that's distance of 3. Pythagorean theorem is 4 squared plus 3 squared equals, that's a Pythagorean triple. I already know that one. That one should be 5. Right? That's 16 plus 9, which is 25. Take the square root. C is indeed 5. We are good to go. Y'all, good luck with this test. Hope you have a great day. I probably won't be here for it. If I am, awesome. If I'm not, we'll see you soon.